Yeah, this is Raghu Bala with your Module 2 roundup video. So this week we covered the topic of machine learning. So firstly, we'll begin the definition of machine learning, which was given to us as machine learning is a discipline that tries to design, understand, and use computer programs that learn from data for the purposes of modeling, prediction, or control. So in the case of prediction, we looked at predicting, let's say, a stock market or collision avoidance or certain types of medical events, catching a particular disease, stuff like that. And then in terms of, the example given was how to predict whether someone likes a movie, and then we used a concept from linear algebra to model what we call a feature vector. And those who want to get further into this discipline of machine learning, linear algebra is very important, usually taught in high school or even early stages of college. But that's a key topic that is used by most of the machine learning programs, whether it be MATLAB, Octave, things of that nature. Even in Python, you need to know linear algebra. So that was what Professor Yakula's videos, he represented that as data. All the features were represented as linear algebra matrices. And then in machine learning, what you do is you have a training set, which is the set of data with which you train your algorithms, and they learn from that. And then what you do is you have your test set, which is the set that you test your system against. And one of the things I wanted to say is um, machine learning is a ongoing process. It requires a feedback loop. So if one thinks that I just punch in some data and then out comes something, output, and that's not the end all be all. Usually it's a feedback loop where you take the learnings from one set of outputs, and then see how it performs in the real world, and then go back and iterate one more time. And that's how a system keeps on learning, which is why you call it machine learning. It's not you learn it once and done. It goes round and round, so to speak, and then it gets more and more accurate. Now, in terms of machine learning itself, there are different forms of machine learning that we went into. First one was supervised learning, and then there was a graph shown to classify sort of hits and misses in supervised learning. And then examples were given as far as classifying images, such as a mushroom was presented, some cherries, pictures of cherries were presented, and so on. Now, in terms of other types of more deep learning algorithms, we very briefly covered convolutional neural networks, recurrent neural networks, and so on, where edges, parts of objects are seen, and then we specify layers of transformation from small features. Next is this type of technology is actually used in scene analysis for self-driving cars, for example, and a number of companies are doing a lot of work in this area, in the Bay Area especially, where a lot of research is going to self-driving cars. For example, Uber, Waymo, and Apple and others. Then another example was using machine learning for translation of language from English to Spanish and stuff like that. And then also we talked about chess, the game of chess versus the game of Go, seeing how one is more complex than the other and how data can be represented. For example, the visual representation of a Go board, how it's a combinatorially a more complicated problem than actually chess, and how how a machine can be taught to play Go. In terms of other types of learning, we also talked about unsupervised learning, and then reinforcement learning. So reinforcement learning is almost like the mice and the maze, or Pavlov's dog theory, where you ring the bell and the dog is fed, and after a while it begins to reinforce this behavior. Whenever a bell is rung, it starts to have hunger pangs, and it knows that food is going to be served and things like that. So So it's kind of similar here, where a mice is trained to go through a maze to find a piece of cheese, and it begins to soon figure out which are the dead ends and how to get to the cheese. So reinforcement learning follows broadly the same sort of principles, actually. And then there was a question about what cannot be machine learned, and chaotic processes cannot be machine learned. Sometimes, I think the example Professor Yakola provided was to do with more nature-oriented things, where where there's a certain amount of predictability. I think he said about something about space. Yes, his example is about space, where the movements of planets or asteroids and things like that are less predictable, chaotic in essence, and cannot be machine learned. Now, two ways of using machine learning. There's both sensing and predicting. And in sensing, in the sensing bucket, a few examples were given: shoegazer, telescopes, a mobile eye. These were in the text of the particular topic. And then in the prediction bucket, we had predicting financial fraud, disease, mechanical failures, crop yields, and so on. And then the examples of I think Group AXA and PayPal for fraud detection was presented as material in the text. And then also a couple of other examples. Professor Alex Pentland talked about how Cogito was taught about attenuating its tone and voice and gestures to increase customer engagement, or at least giving feedback to the human in the form of when to add certain words or set a tone for a conversation so the engagement improves. So here AI is acting like an assistant to the human. And then in terms of personalization, we've all seen this, like Netflix and also Amazon. They have recommendation engines. And then one example is given the text on Stitch Fix for clothing. And this week we saw a number of good posts in the discussion forums. I'm going to highlight three of them. The first one is from Varun Baal, and he had posted a number of links, and these relate to how to frame difficult and easy problems for ML to solve. So not all problems can be easily solved by ML. And so he's given some links that point to articles that classify these problems as being difficult or easy. Second, a link that I'm going to share is from Sumesh Sundareswaran, and he has posted a kind of a timely topic all of our minds, COVID. So how ML can be used to avoid COVID deaths. So there's a link from futurity.org that he has posted that I'm going to share with you. The third set of posts is from David Y. Tai Ng, and he has posted a class of problems that are solvable using ML. And again, these are good examples that all of you who are wondering how to use ML in your organizations can take a look at these examples and perhaps get some ideas and so on. So that brings us to the close of Module 2. Now we move on to Module 3 next week, and that's natural language processing. And stay safe, and we'll catch up with you next week. Thank you.